Hello everyone, so this video will give a highly simplified overview over the do's and don'ts, or better considerations that you have to make when you're using your queue collection RDM on high performance computer clusters. And so we've got our queue collection here. That's the queue RDM. And so on Tinaroo, FlashLite and Bunya, they are visible under Chris data or RDS. They're also visible on the Vina cluster, but I'm only going to talk about it in general from Tinaroo, FlashLite and Bunya. However, similar principles apply if you're accessing these from Vina or from Delta, for example. So we've got our login nodes. And we've got compute nodes. And so each of these, for our clusters for Tinaroo, Bunya and FlashLite, the login node as well as the compute nodes are able to see the queue collection RDMs. So you can access them during your calculations on the compute nodes and also from the login node. Things that need to be considered for this is that the majority or the main allocation that you are given in your queue collection and your queue RDM is on tape. So the main allocation, whether you're 1 terabyte or if you've got 10 or if you've got more, this is given to you on tape. So this is not disk like things like your home directory or the scratch directory. It does not behave like any disk that you have in your laptop or your desktop, for example. And we all know tape is relatively slow. If you've seen movies and other things, you can look it up. You need a robot to basically plug the tapes out, put them into a reader, and then you can get your data off, and the same putting data on. To make it possible for you to access this in a reasonably fast way, which is what you will need for calculations and accessing these queue collection in a HPC environment, is that we put disk in between the tape and where you're accessing the queue RDM from. And so that's something that we call cache. And so this is disk. Now, one of the things that needs to be made, one of the comments that needs to be made is that the majority of allocation, so that is your allocation is here, allocation. And disk, the cache is smaller, because this is only used to funnel your data from the compute nodes to the RDM, or from the RDM to the compute nodes, and the same is true for going from the login node to the queue RDMs. And so this is what you need to keep in mind when you're using an RDM on the high performance computer clusters, is that this cache is not going to accommodate your total allocation. It's only used to funnel your data through. And also, the other thing that you have to remember, that the majority of data will sit here on tape. If it is on tape and you want to use it in a calculation, it has to be recalled from tape into the cache for you to be able to read it and use it. And there's a little bit of time involved as well. So in general, your RDM is reasonably fast, but you can never expect it to be as fast as your Scratch or your Home or a general disk. And also that if you have very, very large files sitting on tape, it might take a while to recall these into the cache for them to be usable. So in a lot of cases, you either have a recall command in your script to recall large files before you use them, or you have to have software that is able to wait for the files to be available. So these are some of the considerations you have to take into account when you're planning your workflows. The other thing is about what data or how data from an RDM can actually be used safely in a calculation. In general, because the RDM has a backup structure in place, and that's done automatically, you should never use an RDM to have your data during your calculations. And that is because if your software produces a lot of temporary files, and if your calculation goes on long enough, they might be ending up in the backups, and because they're temporary files and only used for the calculation and not needed afterwards, that's the last thing you want to happen. You don't want temporary useless files that you have no intention of keeping ending up in the RDM backup structure. So that's the completely wrong way of using it. Also, it's because there is that cache and then going into the queue collection, that kind of little process that's happening for any data going in and out. You should never write continuous output into an RDM directly. So if you're constantly writing a few lines or a few gigabits or even anything like this into an output file, this should not sit on an RDM. Dribbling data into output directly sitting in an RDM will also break that process or can slow it down. And if you slow it down, it means it will be slow for everyone else as well. So a sane way and a more safer way of using an RDM during a calculation is to, for example, make sure you recall your input file and you read a large input, it can be large, in one go into memory into your program that you're going to use. Then you're going to process all of that. And you're writing large output, say to Scratch first or to the temp directory on the compute nodes. Or if you keep all the output in memory and you do one really large write every few hours of final output, or at the end of your calculation it's all written out in one go, then this is what you can do safely to an RDM directly. The other thing that we should never do as well is to sit in an RDM directory and then type qsub directly from there. So that's another thing that is just not a sane and efficient way of using an RDM in your calculations. It's alright to do a whole chunk of read-ins from an RDM at the start, and it's perfectly fine to dump a whole lot of data out into an RDM at the end, and to do this directly without having to go via Home or Scratch or the temporary file system on the compute nodes. But continuous writing, continuous reading, or submitting directly from the RDM are things that you should not do. They can cause all sorts of problems, not just for your own jobs, but for everyone else's as well. So these are general considerations for usage of the RDM and the HPC infrastructure we have at UQ. So please take these into account when you plan your workflows.